Good morning, fellow engineers. I am Dr. Bill, and I am here with my colleagues today, Dr. Nye
and Dr. Science Guy.
We are here representing the student body at University of Waterloo. Today, we are pleased to demonstrate the Catapult at the Toronto Engineering Innovation Conference.
To begin, the word catapult comes from ancient Greek words kata, meaning against, and palein, meaning to hurl. The catapult is an ancient version and closely related to the cannon.
According to Josiah Ober, in early artillery towers, Messenia, Boeotia, Attica, Megarid, the catapult was invented in 399 BC by engineers in the employ of Dionysius of Syracuse.
This is a societal impact as it created employment for engineers. Engineers were hired throughout history to improve upon designs of the original catapult using mathematics.
In the Journal of Science, Dr. Cuomo of the Imperial College of London stated that all parts of a catapult, including the weight or length of the projectile, were proportional to the size of the torsion springs.
Here, we have our design catapult. Behind me, we have a list of variables used with this catapult. To begin, we have L, which is the length of the arm. We then have theta, which is the launch angle. Then we have M, which is the mass of the projectile, followed by K, which is the spring constant. We then have H, which is the launch height of the mass. Over here, we have X, which is the distance mass will travel. We then have Y0, which is the initial height of the projectile. Next, we have Y, which is the height of projectile at any moment. And lastly, we have V0, which is the initial velocity of projectile.
Okay, so for this equation, we're going to be needing a spring constant, which is K, which is expressed in Newton meters. And this is relating to Hooke's law, which is the restoring force of spring is directly proportional to the displacement. So how to find the displacement is, step 1, we need to find the initial velocity of the mass when released from the catapult. So the equation for this is half of the spring constant squared minus the mass times gravity times height, all over half of the mass square root. And we subbed in the variables here, and we came out with the value 2.47 meters per second as the initial velocity.
2, we need to find x, which is the displacement of the mass. So, for that, we use this equation, where y is equal to 0. So, when all the variables have been plugged in, this is what it looks like. When you go through that calculation, you'll find that x is equal to 0.75 meters. So, this is actually the equation for a parabola, which can be shown here, because the trajectory of a catapult is a parabola. So, when y is equal to 0, that is the displacement. In medieval times, the catapult had an environmental and two important societal impacts. There is an environmental impact in the manufacturing of catapults. The catapults were made of wood and iron, which caused a negative impact on forests and mining, since iron is a non-renewable resource.
The catapult had an important societal impact in siege warfare. It was used in battle to batter down walls as well as by defenders to smash siege towers and siege works. The stones they hurled naturally were also effective when used against the densely packed lines of enemy infantry.
The catapult was also a symbol of power and pride. According to Dr. Cuomo, you didn't just have to have catapults to use them. You needed your potential enemy to know that you had catapults so that they would not attack you in the first place.
Oh, sorry, I didn't see you there. In modern day, catapults are much more advanced and have far different uses than what they originally had. They are used on ships where aircraft do not have enough space to do a full takeoff. They are used specifically with steam aircraft catapults and electric aircraft catapults.
Steam aircraft catapults work by using steam that comes from a steam reservoir called a catapult wet accumulator. A catapult wet accumulator blowdown must be done to maintain the water level in the reservoir. It has little impact on environment and is eco-friendly because of the low pollutant loadings and the thermal effects of discharge.
Electric aircraft catapults may soon be introduced to commercial airlines. Currently, commercial airlines takeoff waste a lot of energy. Engineers at Airbus are designing a catapult similar to one used on ships to propel commercial aircrafts. Airplanes will be able to accelerate quicker and more efficiently. This will help reduce fuel consumption and noise pollution, which has a positive impact on environment.